this is going to be one of the most important dialogues that you use, this groups dialogue. Now, groups are used for a lot of different things in the Maestro environment, and setting properties is one of the main things that we do with groups. Now, previously, the groups dialog had always had a right-click option to modify properties, but that required the user to create a group. When you go to select, you have to click in this area so that it knows to add things to the group. Add things to the group, say all of these quads. So this group of quads here, I'd have to create the group, go into the groups tree, right-click on it, and say I want to modify the properties, and then it would let me say modify the plating. Or you can modify multiple things at the same time, all operating on what's contained in that group. And then once you modified your properties, if this was a temporary group, you'd have to come in here, delete it to clean up your model space and go back. That was inconvenient. So now, directly from within the groups dialog, you can create, or rather select, all of these quads, and one of the right-click options here is modify properties. So you can do all the same functions, modify everything, but without actually creating the group. You can just have the dialog open. Now, I don't want to change properties there. I want to create beams. So rather than use the beams wizard in the nodal dialog, a feature was added. And with the nodal dialog, you don't actually have to hit the ID button first. It'll allow you to have a blank there and start adding things to the dialog. But it will allow you to create beams quickly by selecting nodes. What it'll do is once I create a single beam, and I'll create one there, and it's pointed downward, but I'm going to make this upward so that it's a little easier to see. Now in the nodal dialog, I can select a group of nodes within that module and then say create beams. Now there's also options for creating aligned beams, and that actually won't work on a strake because you can't modify those nodes. They're fixed in a straight line from one end to the other end of the module. But had these been created with additional nodes, like on those small transverse bulkheads, if you created an aligned beam, it would straighten all of those points between the first and last points in the selection. But if I just go to create beams, it'll then create beams on all of those nodes, and those beams will be identical to the last one that was created. Because we're using strakes, I'm not sure if it'll let you create them outside of this module, but we can give that a try. Let's see. Since we're just selecting nodes, and that one is not on the strake that I wanted, that node. But it's much easier to just click on a large selection. And it did allow me to create beams. They belong to this module, but they're on the points in this module. It most likely created additional nodes on those. If we make this the view part, oh no, I take that back. Maestro was smart enough to know to create those beams on or in that module, even though it wasn't the current module, because the nodes all belonged to that module. That's why the beams were created there. And you'll see it failed to create this last beam, even though I did select that node. The problem was, I think the one that actually got selected was when I clicked on this node and that one, it selected them from two different modules. I think it selected the node from the intermediate module rather than the node from this module, and that's why it couldn't create that beam. I can see here that now it's selected endpoint 5, nodes 9 and 10, so they're in the same module. Now if I say create beams, it should work, and it did. That's another thing that when we go to query a node and see where it is in 3D space, you can get other information about the node. You can see its FE tag number, as I mentioned earlier. Everything has an associated FE tag in there. And if you have coincident nodes, as we do here, the one I am hovering on, you can see is top insert, and it's endpoint 3, section 0. So it's the first node on endpoint 3 of the insert. But at the bottom, you'll see what other nodes coincide with it. So there's also a node from top being 0 and 0.3, section 0. But at any rate, the idea there was to let you know that it does display when there's more than one node at a given location. That's one way to find out how many are there and what they belong to. There's a number of different types of groups. A general group is just any collection of elements from your model. The volume groups are specific to defining tanks. The plate groups are for selecting various quads and tri-type elements, and that's typically used for assigning a mass. And you can see it even brings up this mass option here, and it's for, say, defining cargo weights on a deck or something like that. And the nodal groups are just the nodes from a collection of nodes within the model. And they're also useful for assigning weights. And you see there is a mass associated there. And for a nodal group, you can define a single mass for the group, but you can have any number of nodes within it. Now, if it's a main engine and there's only one main engine, you can just have one node and a very large mass associated with the engine. But let's say you have port and starboard diesel generators, and they're identical pieces of equipment. You can put in the mass of both of them into this item and then put both centroids in there, and Maestro will evenly distribute the weight amongst all of the nodes defined in there. And then each node in the model can have its own RBE element to tie it to its foundation or its contact points on the deck. But the mass of the node would just be an even distribution of whatever number is defined here. Another thing is, if we were to define a general group, and I'm going to grab this whole module and put it in a general group. So we'll create that one here. If I had a plate group in here, and I'll just put one, I just want to build a sample plate group. And if I view my general group here, it has everything from that module. But if I drag this into the plate group, a plate group can only have plate elements in it. So when I move that group from a general group, which can contain anything, to a plate group, anything that wasn't plate got removed from the group. Similarly, if I were to have a nodal group, it has to be an additional node, I guess. Go ahead and create that. So I'm going to delete that nodal group, but I'm going to drag my plate group that we're looking at here into the nodal group, and now we just have all of the nodes from that plate group in there. And that actually can be useful to quickly select a number of points or something. What we could do is, now that this was the full module, but if we come back in here and I just needed a few points, and I grab these three elements, and I'm really just interested in the nodes. So this is going to cause me an error, I think, if I try and drag it in there. They have the same name. I'm going to modify this name first, and I'll view it here, drag it into the nodal group. You can see I have those 8 nodes that defined that group. And having a collection of nodes can be useful not only for when you are assigning weights and things like that. It can also be useful if there are specific locations on the hull that you want to record displacements from during an analysis. An example would be a project where we were doing a dry docking of a vessel, and it was a floating dry dock. And in the dry dock, they have a visual sight system so that they know that the dry dock is still flat. And basically they have a set of targets along the length of one of the walls on the dry dock. I think there were 6 of them along the length of the dry dock. And each day they can do a visual sighting down there to determine, the displacements up and down at various lengths along the length of the dry dock. And they can adjust the ballast to bring it back into level so that there's no sag or hog in the dock. And what we did when we were doing a simulation for various load conditions on the dry dock, was we had a collection of those 6 points. It was a nodal group along those locations on the side of the dry dock. And for each different load condition that we did, we had that nodal group there, and all we had to do was display that nodal group, and under results, you can say list nodes. And no, we don't have results here, so we don't have a dx, dy, dz, but it showed a group of 6 nodes, and for each load condition, when we just ran this little display or list nodes, you got those 6 nodes and their x, y, and z displacements for that load condition, which was kind of handy for comparison purposes. So they can be used for different things.